Okay, on to the next video. So here we go. So this is problem number 8 in our paper 1 foldable that we're going through, and just put it in the problems that you need. So if you don't need number 8, move on and don't put this one in. So this was the one that we are going to do a t-test. And so it gave us this table, and it said a t-test had to be performed at the 5% significance level. And so one of the things on this one, as you solve this one, you needed to know that the significance level that we were going to be doing was the 5% significance. And so you had to write down the null and the alternative. Well, when this one started off and it said that we were doing a t-test, one of the things that I told you guys, when you were doing a t-test, the letter T meant that you were testing mean 1 to mean 2. T-test is the mean. Chi-squared, test of independence, is that really long word, and you're testing something is independent of something else. So the t-test meant that we were comparing the means. So when you had to do the null and the alternative, we were comparing the means. Now, on this particular one, it said that the aim was to find out whether the chinchilla rabbits are generally heavier than the sable rabbits. So we basically are saying that, well, let's say that the weights are the same, that they're equal, or we want to say that, no, the chinchillas are heavier than the sables. That would be our means. Now, another way that some people chose to do it were to say that the means equaled 0. So another way you could have said was mean 1 minus mean 2 was 0. The null was where they equaled 0. And then the other one was that they were greater than 0. When we taught it, I always did that they were equal or that they were, one was greater than. Just remember that they can't, the alternative cannot be equal. All right, and that was all you had to do on part A. And then on part B, you had to find the p-value. So you had to go to your calculator and you had to do stat. Oh my goodness, my calculator's a hot mess. And you had to plug in all those values right there. And then you had to do a stat test. So I'm going to go ahead and plug them in because I feel like we need to do this. So I'm going to start here at 4.9. I'm going to do 4.2, 4.1. You can fast forward this if you just want to get to where I actually work it, because it's going to take me a minute here to get all these in. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then the other side is 4.2. 4.1, 4.1, 4.2, 4.5, 4.4, 4.5, 3.9, 4.2, 4.0. Okay, and we are doing a t-test. So stat, calculate. We're doing the t-test. So we're going to do a 2-sample t-test. We're comparing list 1 to list 2. We are doing that they are not equal. Nope, we're doing, I'm sorry, that they're greater than. Make sure I was in my window there. We always did that it was pooled. And our p-value was 0.0408. So I'm going to say that p was approximately 0.0408065844, and then I'm going to do 3 sig figs, 0.0412. Okay, so here's my first significant figure is the 4. 1, 2, 3. So I'm going out to the 8. 0, 8. The 0 behind it won't change, and so it's going to be this right here. And so when I look at that, I'm going to go back and it said find the p-value. So there's my p-value. Then the next thing I'm going to do is go back up here to C. And the C says write down the conclusion of the test. All right, so here's my C. So now I need to see P 0.04. Okay, so this is smaller than this, correct? So P is less than alpha, right? P is smaller. If the P is low, the hoe must go. Remember, we said we reject the null, right? So, therefore, P is less than alpha. Therefore, we reject the null or the hoe, and we can conclude, as long as you have that you're rejecting the null, you're good. I'm going to go ahead and say what we conclude. We can conclude that the chinchilla rabbits are statistically heavier, and conclude that I probably will not spell this right, the chinchilla, yeah, it looks good, rabbits are statistically heavier because we rejected the hoe. So that means they're not equal. We're going to conclude that the alternative, which is that the chinchillas are greater than the sables, whatever the other ones were. Sables, yeah. So we're going to conclude that. All right, I'm going to draw my line here, and I'm going to move on to my next one. Oops, there we go. I like the t-test. It's probably my favorite one to do because I feel like it's the easiest one to do. I like how it does. Oh, okay. Oh, I love number 8, y'all. Number 8 was number 9 was one of my favorite ones on here. Okay, so number 9. I'm going to put my picture on here. So if you need help with this one, put your picture in, draw it in, glue it in, whatever you are doing. Here we go. Number 9, we've got the gardener. He's got the small town. Here we go. We've got straight borders. We've got the lawn is shown. We need a footpath is to be laid around the curve. All right, so we've got this footpath here. It's going to be laid around the curve. That was the key to this one. You had to understand that footpath was going around the curve, okay? Now, the footpath is going to be around. We had to find the length of the footpath. So on this one, in order to find the length of the footpath, you had to realize that was the arc, right? You needed to find the length of the arc. Well, you had a formula. Theta over 360 times 2 pi r. This one was nothing more than realizing that formula, and then once you knew that, you could figure it out. You already knew that theta was 135 times 3, or divided by 360 equals 2 pi. Did we know r? We sure did. We knew r was 6. And so you simply plugged it all in, and I got it was 4.5 pi. And I went ahead and converted it and got 14.137166 and went one step further and got 14.1 meters. And then for part B, you simply had to find the area of the shaded region, right? Find the area of the lawn. So you had to find this area right here. That meant you needed to find the area of the entire sector. So let's find the area of the sector. And then we had to find the area of the triangle minus the area of the triangle, and that would equal the area of the shaded. Okay? So let's find the area of the sector. Well, you have a formula for the area of the sector. So let's do area of the sector, and that is theta divided by 360 times pi r squared. Okay, so the area of the sector, theta is 135 divided by 360 times pi times r squared. All right, that's not too terribly hard to work right there. When you do that, then we're going to do, oh, you know what? I actually did not work that out in my notes. Oh, whoops. Okay, here we go. I'm going to leave that right there. I'm going to do this. I'm going to actually not do that. That's my area of the sector. Minus the area of the triangle. So I'm going to come over here and I'm going to do area of the triangle. Area of the triangle is 1/2 A, B, sine of C, right? Because that's not a right triangle. Oh. Okay, so here we go. I'm going to put the minus, because I'm doing this one, and now I'm going to say minus 1/2 A. Okay, A. Well, would you be okay saying A is 6, B is 6, and sine of C is 135? Okay. A is 6, B is 6, and sine of C is 135. So here's the area of the sector minus the area of the triangle. What's left is the area of the shaded. Okay, so here we go. The area of the shaded is approximately, because we're about to get into some pi and it's going to be a whole lot of craziness. Here we go. 29.683578. If you didn't get that, remember to have sine in degrees, not radians, and remember to use your pi. And so I'm going to do 3 sig figs on this and get 29 point. The 8's going to round the 6 to a 7, and it's going to be meters squared. All right. I'm going to draw my line. Best problem on the test. Super fun. I love that problem. All right, number 10. Let's see what number 10 is. Okay, number 10, we're going to be using our calculator on this one. And so there's not really much math on this one. This one was Tommaso and Pietro, I guess. And the main thing on this one was to know that you are using the financial app solver. So I'm going to write down here on this one, T was 5 years. This was the time that we were investing it. And you had to know that your rate you were investing was 2.5%. All right. Now what I'm going to do on this one is I'm going to go here on my financial app solver and click that. I'm going to go to my apps and I'm going to go to my financial app solver. TMV solver. All I'm doing is hitting enter. On here, NIPV, PMT, FV, PYCYMT. Okay, I'm going to label what all these are. On your test, when you go to take your test, you can actually, this was probably the only thing that you can write down on your graphing calculator what you did. Okay, so N we are doing 5 years, and then we are compounding half yearly. That means we are, the number of payments, remember N stands for the number of payments, 5 years times twice a year. So you would actually do 5 times 2. You would actually just type that in. And when you hit enter, it does the math for you right there. The interest rate that we are doing, we are getting paid to, oh, was that 7.5? Sorry, 2.75. 2.75%. 2.75. Enter. The present value, what have we got here? We are investing 1,500 euros. Now, because we are putting this money out of our pocket into the bank, think of it like this. We are investing 1,500. So we're paying it. So we're taking it out of our pocket. So it's like a negative value. And it doesn't matter if it's negative or positive. You just have to make sure that either the present value or the payment, somebody in here has to be negative. They can't both be positive. Okay, so I'm going to clear that out. And because sometimes we don't do a payment. Sometimes it's just the present value. So we're going to see. We're probably not making any payments. So we're putting this money into the bank. So we're going to say, you know what? That's coming out of our pocket into the bank's pocket. So they're getting the money. That's a negative. So I'm going to put a negative right here. Then the other thing I'm going to say, the payment, I'm going to leave that blank for right now. The future value, FV. That's what I'm trying to find, right? Calculate the amount Petro will have in his account after 5 years. That's what I'm wanting to find. Now, the payments per year, we are doing 2 payments per year. So I'm going to put that at 2. And when I do, the other part is going to go to 2. Now, clear that out. Payments, we're not making payments. So we're going to leave that at 0. The future value is what I want to know. So this right here is what I'm calculating. I do alpha solve, which is the enter button, and it tells me that this is $1,719.49. That is his future value. In 10 years, that's about how much he should have. So I would say that A, his future value is $1,719.49. There's not much to show on that because you're using the financial app solver. All right, then the other one, next one is going to be determine the value of R. So on this next one, I'm going to put B over here. He wants to invest his money in an account such that his investment will increase to 1.5 times the initial amount. So 1.5 times the initial amount, I have to do a little bit of math here to figure out what's 1.5 times the initial amount. Well, you multiply that out and it's $2,250. That's how much he wants to have. So I have to figure out how long is it going to take him, let's see. Okay, to invest, okay, let me read it one more time. I'm sorry, my phone is dinging and distracting me. Timonis wants to invest his money in an account such that his investment will increase to 1.5 times the initial amount in 5 years. Assume that the account pays a nominal interest rate, or R%, compounded quarterly. So he's still doing the same thing. He wants to increase it in 5 years, but now he's getting paid quarterly, which means he's getting paid 4 times a year. But now I don't know the interest rate, but our present value, he's going to invest, let's see, he's going to invest the same $1,500 out of his pocket, but his future value is that he wants to get $2,250. That's how much he's hoping to get. And now we're going to change that payments per year to 4, right? All right, so let's go back to our calculator, and here we go. We're going to go back up here, and we're going to say 5 times 4. We're still doing everything here, but we're going to change this now to $2,250, and we're going to change that to 4 payments. Okay, so we want to know, what's this new interest? What would his interest rate be? We know it should be more. There it is. The interest rate is 8.19206. So I'm going to come down here and say the interest rate would be 8.19%. All right. There is that one. All right. Let me answer this text back real quick. We'll be home by 5 for sure. Awesome. Okay. And let me draw the line. And on to number 11. Ooh, I just made my line a little crooked on that one. That's okay. Okay, number 11. Okay, number 11. The newspaper vendor in Singapore. So here we go. This one, I believe, was our chi-squared test on this one. Okay, so this one we've got, I'm going to glue this one in. Oh, got a little bit too much glue on that one. That's okay. I'm on the last page, yeah, I am. All right, So this one was the newspaper vendor, and yes, this one was the goodness of fit. And remember, goodness of fit are usually our easier ones whenever we go to work those. Like, they don't usually take us as much time. So they give us everything on this one. They already give us our null and our alternative. They've written it out. Find an estimate of how many copies the vendor expects to sell each day. So on this one, they want to know the expected value, right? So you can go right to your stat. And if you're like, oh, I don't remember on the goodness of fit, which one am I doing? Remember, you can go to your stat and go to your goodness of fit test and hit enter. And it tells you L1 and L2, right? So remember, you can go, oh yeah, I'm doing the L's. So you can go to stat, edit, clear this out because we were just doing that other one. And let's put in our values here. So for L1, we're putting 74, 97, 91, 86, and 112. And then what you may have trouble with is, ooh, how many am I expected? And you might have to go back and read what was your expected. Well, it said in here that, let's see, the newspaper vendor is trying to predict, and let's see, each day, according to the model, she expected to sell the same number. Okay, she was expecting to do the same number of newspapers each day. So these should be the same number, but they're obviously not. The question is, what was the number she was expecting to do? So I have to go back and read in my problem to find out what was the number she was expecting to do. Okay, it's not jumping out at me, so I'm going to have to read. The newspaper vendor in Singapore is trying to predict how many copies of the Straits Times they will sell. The vendor forms a model to predict the number of copies sold each weekday according to the model. They expect the same number of copies will be sold each day. To test the model, they record the number of copies sold each day during a particular week. This data is shown in the table. Okay. The goodness of fit is performed at the 5% significant level. Determine the vendor's model. The critical value is 9.49. Estimate the number. Expected is the average. So let me go into stat, calculate the average. Oh, I think I messed that up. Stat, calculate Y bars. Let's do second L1. Yep. Okay. So I need to figure out what the average, I need to figure out what X bar is. What is the average? Oops. What is the average newspaper sold? So I could just add these up. 1, 2, 3, 4, 5. And so it might be easier just to average them. I was kind of lazy just then. And what I did was I went to my calculator and I knew I had this in here. And I know from statistics, I've done it enough, that if I just do a one variable statistics and I do it in L1, because that's where all my data is, X bar is the average. And the sum of all the X's is 460. And if I take the average, it's 92. So I've kind of gotten lazy in that I know X bar is the average. So if she wanted to sell the same number, then the expected number is that she was going to sell 92. So that means she expects to sell 92 every day because that's the average number. So I'm going to go back to my stat, edit, and I'm going to put in 92 every day because that's how many she expects to sell, the average number. Okay, so I've got all those in. So find an estimate for how many copies a vendor expects to sell each day. Expecting to sell is 92. And then B. B is write down the degrees of freedom of this test. Okay, well, the degrees of freedom, and again, this is not in your formula booklet, the degrees of freedom. So for the goodness of fit, remember it's n minus 1. 1, 2, 3, 4, 5. So it is 5 minus 1, which is 4. So I would just simply say it's 4. Okay, C. Actually, I wonder if I could put, well, oh, there's not a C. Sorry. This is still on B. Okay. The next part is write down the conclusion of the test. Give the answer for your reason. Okay. So here's all my stuff. I'm going to go into stat. Move it over here so we can see a little better. I'm going to go to calculate. I'm going to do a goodness of fit. L1 is the observed. L2, the degrees of freedom is 4. And we're going to calculate this. Okay. So here's what we've got. Chi-squared is 8.54. The p-value is 0.07. So the best way on your IB exam to demonstrate chi-squared and show your knowledge of it is to draw this. So here's what we've got. We know that this over here, and you can even say this is the rejection zone. You can say that. Rejection, I can't talk today. Rejection zone. The critical value it gave you, the critical value on this right here was 9.49. Now, what I found on mine is the chi-squared was 8.54. You end up at 8.54. You cannot reject this, right? Because you're not in the rejection zone. Therefore, you cannot, you failed to reject it. You cannot reject the null. You fail to reject the null. You don't. You fail to reject it. We do not reject the statement that the data satisfies the model. The P is low, the home must go, right? We can't. The P is not low. The P is bigger. You could say that P is bigger than, or not P. I guess on this, well, I guess we could. We could say our chi-squared is bigger. Our chi-squared is less than. Let's say it that way. We could say that chi-squared is less than the critical value. Because it is. Our chi-squared is less than the critical value. So anyway, goodness of fit is super easy to do. Count on that being on your test because it's such an easy one that I do think that will be on your test again this year. They like the goodness of it. Be prepared. In the words of Scar. Be prepared. Okay, 12. We are putting my little graph on here. And again, just because they had it on there last year doesn't mean it's going to be on there this year. Chances are not good that they'll do anything like what we did last year. But, you know, just be prepared. Okay, consider this function here. What we're going to do is make sure you can see it for one, because right now you can't. Oh, and is that crooked? Yeah, that is a little crooked. Oh. Okay, let me see if I can get it straighter. Okay, I can't really get it straight. Okay, so in our booklet, we are on number 12, and we need to consider that the graph of f of x is shown in this diagram. It's got this vertex. We've got things labeled. And what we want to know is it wants us to find the value of p over here. So really the only thing it gave us was that this right here was at negative 2, 0. But we do know that this right here is the axis of symmetry, right? And we know that this value is at x equals 0.5. So that would mean that this right here is 2.05, right? This is 2.5. So are you okay saying I just need to go 2.5 over? So that would mean that P would be at 2.5. You would have to go over. You would have to go over 0.5 and then go over 2.5 more, which would put you at 3. right? Because you have to go over 0.5, and then this whole distance here is 2.5. So that would be P would be at 3. So that would be our first point, and that one was pretty straightforward when you got it. Okay, so then our B was find the values of A, B, and C. Okay, so where's A, B, and C? I don't even see A. Oh, there it is. Sorry, didn't see it. I wasn't even looking. F of x equals, we've got ax squared plus bx plus c. Oh yeah, there we go. Okay, so you know what? I honestly on this one, I think I would just do a regression and I would label my points. So I've got -2, 0. I've got 3, 0. And I've got 0.5 and -12.5. I've got 3 points. If I've got 3 points on a quadratic, I'm going to go to Stat, Edit, and I'm going to use my points right here. So I'm going to go -2, enter, 0.5, enter, and 3, enter. And then -2, 0, oh, no, I'm not. Clear that out, delete. There we go. Okay, -2, 0, 0.5 is -12.5, and 3 is at 0, and then that one I need to delete. Okay, Stat, calculate quadratics. Okay, so there it is. So I would say that A is 2, B is -2, and C is -12. A, B, and C, and then C was write down the equation of the axis of symmetry. Well, the axis of symmetry is pretty, I mean, you can see that one right there. It's 0.5. You didn't even have to do part B on that one. There we go. Oh, wow. That one was a whole lot easier than I thought. Golly. Y'all should not have missed that one. That one should have been real straightforward. Okay, 13. Was this the last one? Okay, 13 is the last one, and I did have a lot of work on this one, but I am going to try and just squeeze it in right here if I can. I hope. I'm hoping I can. Okay, it's the only calculus one that was on here, and I'm just going to see if I can squeeze it in right there. Okay, I'm going to draw a line down right there. All right, this is number 13. Last one. So on this one, the first thing you had to do was find the derivative, p prime of x, right? The derivative with respect to x. So I'm going to find p prime of x. So -1.6x plus 48. Well, the derivative, or oh, that was the derivative. Sorry. So I'm sorry. -1.6x plus 48. That was the derivative. Find an expression for p in terms of x. I'm finding the antiderivative. I did not catch that. Okay, so we need to find p of x. So we need to take the antiderivative. So I'm trying to think which way. You did have to know your antiderivative rule. So remember when we did f of, let's see, how did it write it in our, I don't remember how it wrote it in our, where was my, oh, here it was. F prime of x was nx to the n minus 1. And so I needed to go the other direction. I need to put the integral one on there, y'all. I need to put the other direction on there. All right, so we're going to have, let's see, a, so that'll be -1.6 over, and then it'll be the 1 plus 1 times x to the 1 plus 1 plus 48, and then we'll add the x, and then we'll add c to that. So that's going to be -1.6 over 2, and so I'm going to go ahead and make that. So that's going to be p of x equals, I'm going to simplify this all together. So that'll be 0.8 x squared plus 48 x plus c. Okay. Find an expression for p in terms of x. And did it give us anything about the company, rate of change, cars, X? The company makes a profit of 2. And oh, they sure did. The company, let me get that F out of the way. I didn't catch that either. The company makes a profit of 260 cars, $60,000 when they produce 15 electric cars. That was their profit. So we do have to find C. This was the profit, $260,000, negative 0.8 at 15 cars, plus 48, 15, plus C. Okay, so we are going to have to solve that for C. Now, I'm going to do all of that in my calculator in one fell swoop, and that's going to give me that C equals negative 280. That's just algebra right there. That's just a big old algebra. So here's what that's going to give me. And I'm going to kind of, well, I could just write here. P of x is going to equal negative 0.8 x squared plus 48x minus 280. So that's going to give me that. And that is part A. Okay. Then it says that the cars increase in the number it produces. Describe how the profit changes if they increase production to over 30 cars per month and up to 50 cars per month. Justify your answer. Okay. So this is part B. So here, oh, come on, little pen. Hang with me. You can do it. We're almost done. I'm going to fix this. All right, here we go. Okay. So here's what's happened. I am going to graph that. And it doesn't really matter. Negative 0.8 x squared plus 48x. It doesn't, I mean, it's a parabola, right? Minus 280. So I don't think it really matters that I can even see this. Yeah, so it's over here. So let me do my window. Let me move my x to like 100. Let's see if that helps. Okay, so it's going to go up and then it's going to come down over here. So it's looking like this. It's coming up and it's coming down. And it really doesn't matter exactly what it looks like. It did make a comment, though, that describe how their profit changes if they increase production to over 30 cars per month. So if they increase it to over 30 cars. So remember, the x-axis is the, this is the cars, and then the money is the other one. So let's go here. Let's make this to like, let's go here. Let's look at the y value. So let's go here. Let's look at 30. What happens if we go to 30? 30, we're at 440. And then what happens if we go to 50? Oh, 50, we go down. Did you catch that? 50, we go down. Okay, so let's go to our window, and let's go to the Y, and let's make it go up to 500. Let's graph it. Okay, so let's do second, calculate. Let's calculate that maximum. So let's come over here. Why am I calculating the maximum? 30, 440. Okay, so this point right here is 30, 440. Right there's the maximum point. So 50 is going to be over here, right? Let's just see. What happened? Where's, let's do trace. Let's go over here and let's find 50. There's 50. 50 is like right there. 50, the profit is 102. So 50's over here, and it's 50, 102. So here's what it asked us. What happens? Describe how the profit changes if they increase production to over 30 cars per month and up to 50 cars per month. What happens to their profit? Their profit decreases, doesn't it? Maximum profit happens at 30 cars. And then what happens after 30 cars? They begin to lose or decline, or profit begins to decrease after 30 cars. So they lose money if they make more than 30 cars. The main thing on this problem is that what they want to see. They want you to talk about how they're making money if they make up to 30 cars. But after 30 cars, they begin to lose money. They're losing money on the backside. That company's not making any money. All right. So I hope that that helps you with your paper one. And I just want to recap. I know we're at the tail end of this, but what your booklet should look like is now you've got problems you struggled with at the back. And now my booklet, I did all the problems. Your booklet may not have that. And then what I'm going to do on the back is I'm going to give you a couple more pointers to put on there as well. If you didn't watch the other videos, go back and check them out. They're pretty good.